Hey, good morning, guys. Mr. Letty, starting our new unit, Geologic History. This is the last official unit of the class, and then we'll end the class with something a little more fun based on that survey that is sent out. If you haven't answered that, please go to Classroom and take care of that so you can kind of control what it is you want to learn. Right now, the changes of Long Island are leading the way above oceanography. Um, and then some people are putting in some weird other choices that we can't learn about. So when you put about things like the human body and things like that, remember you're taking a whole class on that next year. That's living environment. Earth science, we're not dealing with a lot of stuff that's alive. All right. So in geologic history, what exactly are we going to be learning? Okay, so we learn a lot about the geologic time scale. All right, so we're going to put some things in perspective for you. How long people have been on the Earth, how long there's been life, how long that life has been complicated, um, comparing the dinosaurs to how long people have been around, things like that. Okay, we're going to talk about things like extinction events. All right, so these big events that happen where many, many, many things die over a short period of time. Could be up to 95% of everything that's alive on Earth dies. Okay. Something with interpreting rock layers. So when we look at a layer, being able to figure out the story behind that layer, which again doesn't sound real exciting, but there are jobs where if you are able to do this, you can work for, let's say, an energy company, and you might be able to help them find where they're going to find deposits of natural gas or oil. And if you do that, you could be making quite a lot of money. All right, well into the six figures, and you get to travel all over the place. Okay, something called an unconformity, which we'll get into that. Sequencing of events. So if you like puzzles, it's kind of similar to solving puzzles. Relative age and radioactive decay. All right, so we talk a little bit about radioactivity and things like half life and things like that. So you'll learn a little bit about that. All right, so let's move on. Oh, yeah, half life said that. Okay, so why learn about geologic history? All right, so reading the rock layers, we look for patterns and cycles that develop in the earth. So if we're doing that, we know where to look, as I just said earlier, about things like precious metals. So the things that go into your cell phone, all right, metals that you've never heard of before that are very, very, very valuable, and that if you can find them, people like Apple and people like Samsung, uh, Intel, companies like that are would pay quite a lot of money to get access to that. Okay, so diamonds, gold, oil, natural gas. All right, um, looking for patterns in climate change. So as we look over history, we can see what the climate was like. Okay, so putting the political side to the climate change debate aside, okay, not talking of politics, um, everyone agrees that the Earth is in fact getting warmer. But did you know that the Earth has in fact been much warmer than it is right now? So we've had periods of time where the temperature on the Earth is much, much greater than it is now. And it's changed the way the Earth functions, what the animals are like, what the plants are like, and all of that. All right. So ice ages, volcanic events, whatever. We can kind of go into all those and figure them out. Okay. So the Earth has existed for 4.6 billion years. Okay. So that is quite a lot of time. All right. Humans, or things that you would consider human, have been around for 1 million years. Okay. So if you do that as a percentage, you're going to find out that we have been around, as far as people or things you would consider people on the earth, for less than 1/10 of 1% of all of Earth's existence. barely the blink of an eye as far as the Earth is concerned. Okay? All right. Just kind of another way of putting in the time scale. A little confusing, so we're going to skip over that. All right. As we're talking about a time scale, so there are certain things you're going to need to understand, and that's how we break up the time scale. So why do I say that we're going from one time to another time? All right. What makes it change? Why is it one thing over the other? So we have various lengths of time, eons being the longest, eras, periods, epochs. Okay. And those would continue down. All right. You'd have centuries and decades and years and such, so on. All right. Now, why do we change from one to the other? Well, if there's a minor change, so let's say when the dinosaurs went extinct, that doesn't change the eon at all. That doesn't necessarily change the era. Could just change the period. Okay. Um, so it depends on what took place. When you have a really big mass extinction, that usually marks a significant end in a period of time, and then we move on to other things. Okay. Now, when I say mass extinction, I'm not talking about in one day. Okay, the sun comes up and then 95% of everything on Earth dies before the sun goes back down. All right. This could take place over 100,000 years. But again, if the Earth is 4.6 billion years old, 100,000 years is nothing as far as the Earth is concerned. Okay, that's again very, very small amount of time. Okay, so I said this eons down to eras to periods to epochs, millennium, century, decade, year, month, week, day, hours, minutes, seconds, and so on. Okay, so this is how time breaks down. All right. Before I go too far into this, we're going to have another video that I'm going to record where I'm going to show you pages 8 and 9 of the reference table and how to read that so we can learn a little bit about some of these things. So we'll go a little bit into the Permian extinction, but not too far because I don't want to get too ahead of the notes and I confuse you on things. You'll see another video tomorrow based on reading the reference table, and then we'll pick up the videos and the notes next week, which is a short week. We have Monday off because of the Memorial Day holiday. I know you're stuck at home, so it doesn't feel like having a day off is that big of a deal. But there'll be no work posted, nothing going on from me on Monday. All right, so real quick, the Permian extinction. Okay, it's the largest extinction event we can find records of. All right, it happened 251 million years ago, and 95% of everything that was alive dies. All right, so this is like the biggest mass extinction we know of. All right, so if you lived on land, you did slightly better than the things that lived in the oceans. Okay, so we're not 100% sure why it happened. The one thing on here that you're going to notice is going to come up more than once, and we talked a little bit about this in a previous unit, is a change in the magnetic poles. All right, so if you remember when we talked about they were studying the Mid-Atlantic Ridge after World War II, and you had the iron, and it was pointing north, and then all of a sudden it's pointing south on the other side, and then it's pointing north again, and then south, and I said that each one of those lines up with an extinction event. These are what we're talking about here. Now, kind of key to understand is 251 million years ago, you have this extinction event. Our ancestors were part of the 5% that survived. Okay? So, not saying there were people 251 million years ago, there were not people. But the things that would ultimately become people, okay, survived this. If they didn't, we obviously wouldn't be here. Okay? So, big event. All right, and it's going to mark The change in eras. So again, we're not talking about a change in eons. We're more eons. There has been one change, and that usually is broken down to no life, life. Okay, so that's a really big event. Life shows up, we make that a new eon. Then when we go to the eras, we're talking about really, really, really big events. So similar to this, we end the Paleozoic era and we start the Mesozoic era. Okay, so this was a big, big event. The dominant life forms changed 100%. All right, so we had one type of life form that was the dominant form of life, and that goes away. Okay, and in the Mesozoic, we're going to call the age of dinosaurs, which is where we're going to stop. Okay, because we're going to have a project that we're going to start talking about next week about dinosaurs, um, and let you guys do some research on whatever particular dinosaur you happen to like, and we'll take it from there. All right. So look for a video tomorrow, guys. It's going to talk about the reference table. That's only going to be about 10 minutes long or so, but kind of important that you know how to read this page so you can follow along with what we're doing, and it's going to help you out on that project. All right. A little windy today, but get out there and enjoy the nice weather. We should have turned a corner to where at least the temperatures should be warm enough. Uh, I know personally, I just finished planting all my vegetables, so my garden is up and running. I know, kind of geeky, but whatever. It's what I like to do. All right, and hopefully everybody's being safe. And I will talk to you guys soon.